Hi and hello dear friends, welcome back once again to our channel VAAGAI Academy of Mathematics, and this playlist is where you can find video lessons for CBSE Class 7 Applied Mathematics. And we are seeing the topic time, speed and distance. We have already completed the first 4 chapters of time, speed and distance, and this session is going to be the last session, chapter 5 of time, speed and distance. So in those first 4 chapters we have already seen the basics of time, speed and distance. What is the relation between these 3 quantities, and what happens if we are going to fix any 2, or if you are going to fix any one as constant, and what happens to the other 2, how they are going to vary. All those things we have seen there. And also we have seen about what is average speed, what is relative speed, everything we have seen in those first 4 chapters. We also worked out many sample problems there in those sessions. And here, this last session, chapter 5, we are going to see train problems. This is going to be another very important topic. And as far as this aptitude exams are concerned, you can definitely find questions based on this train problems. You will definitely be able to find problems based on this train concepts, and it's going to be very much important. And those train problems, the concept of train problems are what we are going to discuss here in this lesson. Okay, yes. And another thing is, what about this train problems and what kind of questions we can expect in this train problems? You may have that doubt. Whenever we talk about this train problems, we will always find problems based on a train which is going to cross some object, or it is going to pass some object. For example, a train is there, a train is going to travel, it is traveling in the track, and there is some object outside the track. And what happens, or how much time it would take for the train to cross that object, or a train is going to cross another train, they are going to pass each other, how much time it would take, or what speed it should travel, in what speed the train should travel such so that it would cross the other train within this much time. So this kind of crossing way we will be getting the problems under this train concept. Okay, and here to work the problems based on this train problems, there are 4 basic important cases. So if you know about these cases, you can be very sure about solving the problems very easily. So those important 4 concepts are what now we are going to discuss. First we'll finish off them, then it would be very easy for us to solve the problems. Yes, yeah, we'll start. And yeah, 4 cases, we'll see them one by one. Case 1 is going to be train crossing objects like a pole, a signal post, a tree, and so on. You can just see these objects very carefully. The objects are pole, signal post, tree, like this. They are going to be, all of these are single point objects. That is, they don't have any big length at all. Their length or the width, it is going to be very much negligible when you compare it with the whole length of the train. Yes, correct? So this way, a train is going to cross these kind of objects. Then what happens about the distance and speed? These 2 things we have to calculate. So we must see what is the distance and what is the speed. Why? Because if we know about distance and speed, it would be very easy for us to find the time, because time is equal to distance divided by speed. Is it or not? So let's see what would be the distance and what would be the speed when a train is going to cross objects like this. You mean single point objects? Yes? Yeah, fine. Coming to distance. So imagine a train is going to cross objects like pole, tree, signal post, like this. Okay, or it can be a stationary man, like this. It can be anyone, right? So what happens is, let me take an example. I will take another marker like this. Okay, so imagine this marker is going to be a signal post, or it can be a tree, whatever it is, any single point objects as defined here. And say this another blue marker, let us take this blue marker to be the train. You imagine a train is going to cross this object like this. So what happens? This train is going to cross this object something like this. And just imagine how much distance this train should travel in order to cross this post or signal post or tree or whatever, this object. Okay, for which the train should cross this object like this. So it's very cool that it is very clear that the train should travel its own length. Is it or not? Why? Because this is going to be the position of the pole, that object. And in that case, if this train wants to cross this object, what happens is it should travel from here to here. So here is where the crossing process happens, is it or not? So in that case, the train must travel its own length. So distance here will be nothing but distance is equal to length of the train itself. Length of the train. So imagine it should travel its own length. So this one we should be very clear. So train crossing objects like pole, signal post and tree, it should travel its own length. That's going to be the distance. And second thing, what about the speed? So here, which object is actually moving? This train is the only object moving, is it or not? So in that case, speed, coming to speed, we have to take speed of the train only. So we'll take speed as speed of the train. Speed of train, that's it. Okay. I hope this first case is clear to you. So when a train is going to cross a single point object, we don't have any special length for those objects. In that case, we should take the distance covered to be equal to the train's own length itself. That's it. So that's a distance, and speed is going to be speed of the train. Obviously, this train is the only object which is going to travel, is it or not? So in that case, we should take speed to be the speed of the train. That's it. And now come to the second case. Second case, train is going to cross objects like bridge, tunnel, or it can be a platform, or it can be another stationary train. So these kind of objects. So they will come under this case 2. So there's a huge difference between objects we see in case 1 and objects we see in case 2. So what's the difference? It's very clear. These are not going to be single point objects. Of course, these objects do have some considerable length, is it or not? So there's a clear difference between a tree, a train is going to cross this tree, and a train is going to cross a tunnel or a bridge which is having some particular length. Is the point clear? So case 2, what happens is, if I'm going to consider this marker, I mean this black marker, to be any of the objects that is mentioned here in case 2, like I'm going to take it as some bridge. Okay, so this is a bridge and the train is going to cross this bridge like this, and we will now examine how much distance this train needs to travel in order to cross this bridge. Okay, fine. For which what we will do is, I'm going to consider this as the train once again. So what happens is, this train is going to come here like this, like this, like this, and here is where the crossing process starts, is it or not? So that means the train should travel a length like this, so that when the train is going to travel from here to here, it has already completed this bridge's length, and from here to here once again, it should travel its own length. So that means to finish this entire process, the train needs to cover a total distance of the length of that object plus the length of the train itself. Is the point clear? So here, the second case, here in this case of distance, what happens is, distance is going to be length of the train plus length of the object. I hope this point is clear to you. So in case 1, we have only single point objects, they don't have any specific length. In that case, we are just considering only the length of the train. But in case 2, we have objects, they do have some length. So that's the reason we are adding up length of the train with length of that object also. Okay, yeah, fine. And yes, coming to speed, what about speed? Here again, which object is moving? The train is the only object which is moving, is it or not? So in that case, here again we should consider speed of the train only. So speed is equal to speed of the train. Okay, yes, I hope this case 2 is clear to you. So case 1 and case 2, they are very much clear to you. And now coming to case 3 and case 4. So once you have very clear idea about case 1 and 2, it's going to be very easy for you to understand case 3 and case 4. So case 3 is almost going to be same as case 1, and case 4 is almost same like case 2. That's it. It's going to be very much simple for you to understand. Let's see what are those 3 and 4, those two cases. So case 3, coming here, train crossing a jogger, an athlete. So train is going to cross objects like this. So what do you mean by a jogger? Who is a jogger? Who is an athlete? So they are going to be moving objects. They are still single point objects, but of course they are not stationary. This time they are going to move. Imagine a jogger. A jogger, when we compare the jogger to the length of the train, the length of the jogger, the width of the jogger is going to be, of course, negligibly small, correct? So in that case, we don't consider the length of the jogger and all. What we consider is, we will just see that the jogger is going to move. That's it, okay? So in that case, here again, distance will be same as what we have in case 1, okay? So case 1 we have length of the train. So again, case 3 also, here again, distance is going to be length of the train. That we will note here. And coming to speed, what about speed here? Here only we should be very careful, right? Here we have the objects, they are going to move. They are not stationary, they are going to move. A jogger or an athlete, they are going to move. So in the case, we have to consider both of their speeds. So when it comes to speed, what do we take? Usually what do we do when we have two objects, both of them are moving? So we will always consider about relative speed, is it or not? So here in this case, we have to see what is the relative speed between the objects, or I can say what is the speed of the object, or what is the speed of the train with respect to the object. So this relative speed we will be considering when it comes to speed. That's it, okay? And last one, case 4 we have. So case 4 is almost same like what we have in case 2. So case 4 we have train crossing another moving train or another running train. So here what happens, this is almost like case 2. So another moving train, a train is going to cross another train. So in that case, here what happens is, both of them are going to have the lengths. So in that case, distance will be nothing but, here we have length of train plus length of object. So same way here, length of our first train plus length of the second train. That's it, okay? So we can take like this. So here when it comes to distance, the train, in order to cross the another train, what happens is, we should take lengths of both the trains, because train 1 is also having some length, train 2 will also have some length, is it or not? So in that case, if I want to consider the total distance, I have to take both the lengths. That's it. So that's what we are taking here. And yes, second one, speed. What about speed? So speed is same like what we have in case 3, is it or not? Because both of them are moving objects. Train 1 is crossing, it is moving. Train 2 is also another moving train. So in that case, both of them are moving objects. So this case again we have to consider the relative speed. I hope you remember what is relative speed. So anyways, I'll just revise it. So relative speed, how do we calculate? Relative speed, again we have two cases. So when we come to calculate what is relative speed, usually what we will do is, we have to consider the directions, is it or not? In what directions the two objects are moving. So if in the case they are moving in the same direction, we have to take the difference between the speeds, and if the two objects are going to move in the opposite directions, we have to consider the sum. I mean, we have to add the two speeds. So this is what we do whenever we talk about relative speed. So all these 4 cases are important, very much important for us to approach any train problem. And now, based on this concept, using these cases, let's try out few sample problems. Yeah, we go. So the first question with us, our question is, a 270-meter long train which is running at a speed of 90 km per hour is going to cross a platform, and it is going to take 18 seconds. So that's what is given. So let's note down the data. A 270-meter long train. So that means this 270 meter is going to be the length of the train. Okay. And it's going to run at a speed of 90 km per hour. So they have given speed of the train also, which is 90 km per hour. And be careful, here the speed is given in terms of kilometer per hour, right? Okay. And it is going to cross a platform. That's another very important information we must note. It's going to cross a platform. Why? Because crossing what object and how, in what manner, that will only decide which case we have to refer, and accordingly what rule we have to use, right? Okay, yeah. So here this is going to cross a platform. So by this time you would have guessed what case we are going to use. All right, yeah. Anyways, we'll continue the question. And in 18 seconds, so for which the train is going to take how much time? Time taken is 18 seconds. So all these pieces are very much important for us to solve the problem. And finally, what is asked in the question? Find the length of the platform. So we are supposed to find the length of the platform. That's it. And as I told, here a train is going to cross a platform. So in that case, it's going to fall over which case? It's none other than case 2, right? So a train is going to cross a platform. A platform is going to be a lengthy object, right? So, and at the same time, platform is a stationary object also. And in that case, this is no doubt, without doubt, we can very clearly say that this problem is a case of case 2 only, right? Okay. So let's note down the things. So for case 2, what do? We should consider the distance as what? So in case 2, we will always take distance as distance is equal to length of our train plus length of that crossing object. Is it or not? So length of the train plus length of the object. So this is what we will usually take. I'm writing in short form. So yeah. And yeah, let's just note whatever things which are given in the question. So in the case, distance is going to be, what is the length of the train? Length of the train, it is given in the first part of the question itself. It is 270 meters. So 270 plus length of the object. What about the length of the object? And that's what is missing in the question. Of course, that is what we are asked to find here in this question. So let's do a thing. I'm going to take or assume this length of the object to be some x meters. Okay, so we'll take it to be x. Usually we'll be using units to be meters only. Okay, so train is going to cross objects. Of course, we do have problems based on kilometers also. Very usually we'll be using this meters only, and we'll maintain the same way. And also it is another thing that we should note here is, here the train's length is again provided in terms of meters only, and it would be very comfortable for us if we consider length of the object also in terms of meters. So in that case, distance is going to be, according to case 2, this distance is going to be 270 plus x meters. This entire thing is now in terms of meters. Okay, yeah, let's have it as it is and continue. What about the speed? So when we come to speed will be equal to what? Speed will be equal to, when case 2, speed is nothing but speed of the train only. Is it or not? So speed of the train, here it is very clearly given. It is 90 km per hour. That we have to be very clear with that. So 90 km per hour. And note that this distance is in terms of meters, and the speed is actually in terms of kilometer per hour. Okay, we should be very careful in the units which are used. And yeah, last we have the time taken also. So what is the time? Time t, I'll mention it as t. So time taken is also given. It is given to be 18 seconds. So this train, it's going to cross this platform at a speed of 90 km per hour, and it is taking how much time? Taking a time of 18 seconds. So time taken is also given in terms of seconds. So now we have to very importantly note these things, and also we should relate all these three quantities. What's the relation between distance, speed and time? It's going to be distance is equal to speed into time. That's it, right? So distance is equal to speed into time. This is what the relation. And what about distance here? Distance, no doubt, we have 270 plus x in terms of meters. And what about speed here? Speed is actually in terms of kilometer per hour, and time, if you see, time is in terms of seconds. So that means it would be better, or we will be able to relate or make an equation only if we have all the terms, all the quantities given in terms of the same units. Only then it is possible for us to equate, right? So here distance is in terms of meters, and time, if you see, it is in terms of seconds. And in that case, it would be comfortable for us if we have the speed in terms of meter per second. Is it or not? Only then we can relate this meters and seconds along with the speed. Is it or not? So let's do a very simple thing. We will convert the speed 90 km per hour in terms of meter per second. Shall we do that? So for which what we do? So kilometer per hour to meter per second. To convert this, what do we do? So just imagine what we have seen in chapter 1. Chapter 1 itself we have seen all these things. And another important thing, please, if you have missed those chapters, kindly see those earlier videos. I mean chapter 1 to 4, all those videos you can see, so that you can very clearly understand what we are doing here. Okay, yeah, come back. 90 km per hour, if I want to convert it into meter per second, so what I have to do? So 90 into 5 by 18, this is what we have to do, correct? because kilometer per hour to meter per second, we have to multiply by 5 by 18. So let's try to do that. So we'll be getting it as 5 times. So 5 5s are, it's going to be 25. And this 25 is now in terms of meter per second. Okay. I hope you are able to understand this. There's no sufficient space. That's why. So 25 meter per second. Now come back here. Now I can very well equate all these terms. So distance is 270 plus x. This is equal to speed now I can take 25 into time, now I can take 18. So 18. Yeah, finished. And yeah, continue. 270 plus x is equal to, what is 25 times of 18? So it's going to be 50 times of 9, right? Because 25 I'll make it as 50 and 18 I'll make it as 9. This is doubled and this is halved. So 50 9s are, it's going to be 450, right? So 450, and now it's easy for us to solve for what is x. So x is equal to actually 450 minus this 270. So we have to subtract 450 minus 270 would give you 180. Is it or not? Yeah, 180. And so x is equal to 180, and of course it is in terms of meters. So what is x for us? X is nothing but the length of the platform. That's how we have assumed it, right? So in that case we have solved for x. So what is the length of the platform? Length of the platform is going to be 180 meters, and that's the answer for our first question. Let us move on to our second question. Our question here is, a train running at a speed of 69 km per hour passes an athlete who is running at a speed of 6 km per hour along the same direction. So along the direction same as the train in 20 seconds. So all these informations are, once again, they are going to be really important. So let's have a note. A train which is running at a speed of 69 km per hour, and it is going to pass an athlete. I mean, it is going to cross an athlete. So by this moment, at this moment itself, you should be able to recognize what case under which this problem will come. Okay. So yeah, a train is going to pass an athlete who is running along the same direction. So the direction is same as the train. That is also very clearly mentioned in the question. And another important thing is, who runs at a speed of 6 km per hour. So athlete is running at a speed of 6 km per hour. And how much time the train is taking to cross this athlete? It is taking 20 seconds. So all the informations are very much important for us. And finally, what is asked in the question? Find the length of the train. That's all. This is going to be the question. So as I told, you should be able to recognize, you should be able to predict what case this problem will fall. So it is very clear that this is under case 3. Okay. So I'll mention this. So this problem will come under case 3. So case 3, I hope you remember, just now we have seen that. So in case 3, what kind of objects you will have? Case 3, you will have single point objects, is it or not? So here is an athlete. Athlete is like a single point object. And in case 3, what is the another important thing? It is going to be, they are not stationary objects, they are going to be moving objects. So here we have an athlete who is also running with some speed. So in that case, this problem is clearly a case 3 problem only. Okay. So case 3, when it comes to case 3, as usual, let's just discuss about what is the distance and what is the speed. Okay. Yeah, fine. So let's note them one by one. So when it comes to distance, what would be the distance? I'll note it here. So distance will be here. It is nothing but the length of the train only, because here the only object which is going to have a length is the train only. So that means distance will be the length of the train. I'm writing in short. And what next? We have to consider the speed. What about the speed here? Speed means here we have to see both these objects. Both of them are in motion, correct? So in that case, we have to consider the relative speed. That's what we have seen there, right? So whenever we have two objects and both of them are moving, so that instance we have to consider the relative speed. And when it comes to relative speed, again we have two subcases, is it or not? So what do we see there? So whether the objects are moving in the same direction or they are moving in the opposite direction, that also matters, right? So here see the objects, they both are moving in the same direction. That is also very clearly given in the question itself. See, in question it will be very clearly mentioned whether they are moving the same direction or opposite direction. That will be very much clear in the question. It will be available there itself. So be clear and carefully see all the data which is given in the question. So here we have same direction. So in that case, we are having train speed to be 69 km per hour. And that athlete speed is going to be 6 km per hour, and they are moving in the same direction. So same direction means what we have to do? So when it comes to relative speed, we have to always take the difference between the speeds, because in same direction we used to take the difference, right? So here also we have to take the relative speed. So it is going to be relative speed, and relative speed here is nothing but 69 kilometer per hour minus 6, because we have to take the difference since it is going to be same direction. So 69 minus 6, this would be 63 kilometer per hour. So now if you see the train speed with respect to the athlete's speed, with respect to the athlete, it would be only 63 kilometer per hour. And what about length of the train? That is not mentioned in the question. And of course, if you see, length of the train is what is asked for us to find. Okay. And what we will do is, as usual, let's just assume some value for the length of the train. I'm going to take it to be some x meters. Okay. And yeah, coming to time taken. What about time taken? Time taken is also very clearly given in the question itself. So time is equal to 20 seconds. Is it or not? Yeah, fine. Okay. Now, as usual, let us try to build a relation between distance, speed and time. So we know that distance is equal to speed into time. So here distance is missing, and distance is what we have taken to be x. And remember, our distance is here in terms of meters. Okay, so I'm taking x meters, so x is equal to, come to speed. What about speed here? Speed is 63, but speed here is in terms of 63 kilometer per hour. And time, if you see, time is in terms of seconds. So that time what we have to do, we cannot directly multiply 63 into 20. Be careful with that, because we may end up with some wrong answer. The speed here is in terms of kilometer per hour, but time is in terms of seconds. So in that case, I have to turn this 63 kilometer per hour in terms of meter per second. Correct? So let's do a thing here. Speed is 63 actually, but when I convert into meter per second, it would become 63 into 5 by 18. Am I right? So now this 63 into 5 by 18, this answer now it will be in terms of meter per second. Okay, without converting it here, I am converting directly here in this step itself. Okay, that's my objective. So I'm not going to waste few steps there. I'm directly doing that calculation here itself. So 63 into 5 by 18. Now I have turned this into meter per second, and this speed now I can multiply by time taken. Time taken is 20 seconds, right? Now I can directly multiply by 20, so that now I have got speed this is in terms of meter per second, and time is this is in terms of seconds. Now when we multiply, what happens? The distance what we will be getting now, it will be automatically in terms of meters. That's our objective. Okay. So yeah, continue. X is equal to, now I think we can cancel in whatever tables, multiplication tables possible. So here we have 63 and here we have 18. So both of them I can cancel using 9 tables. So this is 9 2s are 18 and this is 9 7s are 63, and again easy, this is 2 and 20, this is going to be 10 times exactly. And so we have 7 into 5 into 10. It's very easy for us to calculate. 7 5s are 35 and 35 10s are 350. So 350 meters. Obviously we will be getting our answer in terms of meters only, the distance value. So here x is what we have assumed it to be the distance. So distance here is obviously the length of the train. That's how we took, right? Length of the train is what we have assumed it to be, x actually. So find the length of the train, and what is the answer for the question? 350 meters. So length of the train is 350 meters. This is going to be the answer for the second question. So yes, dear friends, I hope the concept and the problems that we have seen here in this session are very much clear to you. And if at all you have any doubts based on these concepts or problems, you are welcome to comment it here in the comment box. And when I see them, I will see to rectify your doubts. And this is all about this chapter, time, speed and distance. I mean this entire lesson, time, speed and distance. And we have seen all those 5 chapters. This is another important topic which is very much very popular in aptitude here, and have more practice. And again, in our next session, we'll try to catch up with a new topic there, and see you soon there. Thank you so much.